Today I'm going to show you how I connected up my AutoZero touch-off block and how I configured my machine. Hello fellow CNC nuts and welcome. Well, as I promised, I'm going to cover the installation of a touch-off plate like this one here, and I'm going to cover it on two separate videos. One will be covering UCCNC and the other one will be covering Mach 3. So just pick the one that's appropriate to you, or if you're interested, why not watch both? So I've started off with the touch-off plate. In my case, I'm using this here. It's a block aluminium. It's 20 millimeters thick, and it's about 3 inches square. I made this by simply drilling a 4 millimeter hole into it, and that will accept a standard banana plug like so. Now, of course, you don't have to use something like that. Another option is something like this here. This here could be used as a touch-off. It has a single button up here that you can actually push down on. It's not actually a button as such. This here is actually the contact, but if the cutter drives into it and doesn't stop for whatever reason, the button will actually depress, and it gives you a chance to actually manually stop the touch-off process, so should something fail. So that something along these lines is another option. There's plenty of designs for touch-off plates like this. Now, another thing is, it's not possible for me to cover every scenario that there is out there. I'll cover both UCCNC and Mach 3 from the installation of the macros that we'll be using and how to program the required pins and ports. But as far as controllers go, I'll just be covering this one here, which is a Gecko G540 drive, because this is the one that I use. However, what I'm saying basically applies to them all. Now, in general terms, on a CNC machine, some of the pins are set aside on the parallel port for driving the motors, some are set aside as inputs, and others as outputs. So I'm going to show you on here, my Gecko G540 drive, how I connect it up. Here is the parallel port. Now, this connects back to my laptop parallel port, or my smooth stepper, or my UC100, and in actual fact, in my case, a UC300 Ethernet controller. And I'm going to be using pin 10, which is actually the first input port, and it will come out the back here on the G540 as one of these connection ports here. Now, your stepper motor driver, be it a Gecko G540 or a Xylotex unit, a lead shine unit, or hobby CNC, whatever sort of drive you've got, should have the same sort of arrangement. And if it doesn't, you'll have to get a breakout board that will allow you to get access to these pins here. What I like about the Gecko drive is all the outputs and inputs are optically isolated, so there's no chance of damaging the equipment that plugs into it. I don't know about other drives. Now, a touch-off plate is one of the simplest additions you can do to your CNC machine. Simply run a wire from my Gecko drive here, put a banana plug on the end of it, it plugs into the hole I drilled in the side of my block, and I can place the block under the cutter like so. Now, the other end of that wire comes back to here and connects to one of the input pins on the rear of my Gecko drive here, which ultimately makes its way through the parallel port, pin 10. Now, the second wire typically is also run from the Gecko drive and would be terminated with a clip lead. That clip lead simply clips onto the cutter like so, and the other end of it goes back to the Gecko drive's ground. Now, by ground, I mean the negative rail of the Gecko drive's power supply. Do not confuse the Gecko drive's ground with perhaps the spindles ground or earth. They are two entirely separate and potentially isolated circuits. In my case, they were completely isolated. So the earth on your spindle is designed so that if anything goes wrong in here and the body of this here becomes live, then it will be shunted to ground through the 3-pin plug on the wall there, and that will stop me and anybody else around here being electrocuted, for which I'm immensely grateful. Now it's it's possible that you may find the negative rail of your power supply is already connected to mains earth and ultimately may find its way all the way through to the spindle here. I did it by simply running a wire from the negative rail of my Gecko's power supply all the way through to where it could connect to the spindle, and that basically grounded that. Now it's important that should you find that the spindle is already grounded with respect to the power supply of your Gecko drive, do not run a second wire. That will create an earth loop and you'll be chasing faults till the cows come home and you finally figure out what it is and rectify it. Since this here is now connected back to my Gecko drive, I don't need this extra wire anymore, which is going to make my life a bit simpler. However, not all spindles or routers, laminate trimmers or Dremels can be grounded. Some of them have plastic bodies and don't have an earth pin. Some of them, for instance, a high-end spindle may have ceramic bearings, which is going to insulate the collet, the armature here, and therefore you're not going to have grounding. If you're not sure, you can get away with just simply using the clip lead. But there's also a very simple test as well you can do to find out whether or not your equipment is already grounded. Once you've configured up your software, take your clip lead banana plug, touch it to the body or the cutter, and you'll be able to see whether the pin lights up in your software. That's going to be one of the tests you need to do anyway. You need to make sure that that works. If it doesn't, you may find that you will need to go with this clip lead. If it does, then you probably won't need one. Okay, so it's time now to have a look at our software. We're going to start by going to Configuration and across here to Input Output Setup. Now you notice here I've got probe 1 and probe 2, and that's because I'm using a UC300. If I was using a UC100, only probe 1 would be shown here. So next we need to enter the parallel port we're using, which pin it is. So it's going to be pin 10. Just enter 10 and hit the enter key. If you're using a different pin, of course, just enter that there. And on my UC300, I'm using parallel port 2. And I'm going to set it to active low. Next I need to apply settings and save settings. Now that I've done my configuration of the probe, it's time to give it a test. By opening the diagnostic screen, I can see that already port 2, which is the port I'm using on my Ethernet controller, and pin 10, you'll see that it's already lit up. If I'm using the clip lead setup, then simply touching the clip lead to my block here will turn pin 10 off, and you'll also see the probe light turn on. Disconnect it, the probe light goes off, and pin 10 on port 2 comes back on again. Now of course if I'm not using the clip lead but using the cutter through the grounding system, then simply taking my block and touching it against there will do the same thing. You'll find that pin 10 has gone off and the probe light has come on, and if I disconnect it, pin 10 lights back up again and the probe light goes off. If you've got that happening, then all is good and we can move on to installing the macro. And if that isn't happening, you have an issue either with your configuration in UCCNC, or you have a wiring issue that you need to take care of first before we can move on to installing those macros. Well, the first thing we need to do is we need to check which profile we're using in UCCNC. If you open UCCNC and come down here to the bottom, it tells you which profile I'm currently using. In my case, I'm using one called Peter. We can now open our Windows Explorer, go to the C drive, go to the directory labelled UCCNC, and up to another directory called Profiles. And here we can see the profile, and more importantly we can see a directory called macro underscore, in my case, Peter. We'll enter there, and here are the macros we're currently using on our machine. The one we're interested in is M31. The first thing I'm going to do is I'm going to take the old one. I can either delete it, but I'm just going to call it old M31. That just puts it aside if I ever want to come back to it. Next, I've been off to my website and I've downloaded my file, and the file called M31 metric, because I'm using my machine as a metric machine. If you want to know where to find the files, just simply follow the link below this video and you'll be taken off to my website and be able to download it from there. So what I'm going to do is I'm just going to copy that, and I come into my macro directory again and go Control V. And next thing I need to do is I need to just rename that to m31.txt. And there we have it, the macro's installed, but we're not quite finished yet. I'm going to double click on my macro, and that's going to open it up so we can modify what's inside of it. I'll just close that other directory. Okay, now the first thing you'll notice about this macro is the date at the very top. That's when I put it, updated the one on my website. If this here is a younger date than the one you previously have, then consider updating it. And let me start by also saying a big thank you to John Revel here, who created this macro and shared it with the rest of it. I really appreciate it, John. Thank you for all your hard work and for the latest update you did to this, which makes it even easier to use. I really appreciate it. Now, I have done a small modification. I added a date here, but I also created a second version of this here, which has imperial values in here. I've converted the metric ones here to imperial values. They should be perfectly fine, but if you do wish to modify them, these are the major parameters in this area here. The one parameter you do need to change is this one. John's touch-off plate was only 3.09 millimeters in thickness. Mine is 19.88 millimeters thick, so I need to make sure I change that value there. Now, the only other thing you might need to look at is this set here. It's got here to remount the 6 blinds below this one if your machine does not support homing. Mine doesn't support homing, but I'm going to leave it in for the second just to show you what happens if you don't rem those out. So I'm just going to go Save, and I'm just going to minimize this here because I can leave that open and use it in use it in UCCNC. So if we come over here, this is the probing button to probe our touch plate, and because I didn't remount those lines, it's come up with this here. You need to home your machine first. Just go OK. Okay, let's go back to our macro and remount those 6 lines. Like, you do not need to do this if you are using homing switches. Now, to remount a line is very simple. Just go to the line and add a double slash in front of the line, and you're done. Just go File, Save. We can close that now because we're set. And if we come over here to our probing routine again, and I click on it, this time it'll come up with our question box here asking what is the thickness of our material. Okay, now it's time for the nerve-wracking part, checking our macro and hoping that it works as we expect. I'm going to do a couple of things to try and make sure my chances of success are the best they can be. First off, I'm going to take my block here and touch it against the cutter. And by tapping it on and off, if I have a look on my diagnostic screen there, I'll be able to see the probe light going on and off as I do that. Now, if you're really clever and know how to edit the UCCNC screen set, you can add your own probe light to the main screen, then you don't need to go off to the diagnostic page. Another thing I've done is I've changed this cutter to a 3-flute cutter because it's got a much more surface area on the bottom of it, so that if anything does go wrong, it'll cause a minimum damage to my aluminium block here. Don't use a V-bit for this. If you do and it doesn't go right, it'll try and poke a hole into the aluminium block and break the tip off. So a bigger cutter is better, at least for the first test, should anything go wrong. Lastly, I'm going to hold this here in my hand so that it's well above the table here. I'm going to drive the cutter, the Z-axis up nice and high there, and then if it continues moving down after it touches the touch-off plate, then I can simply withdraw the plate and hit the emergency stop switch. So enough chatting about it, let's give it a try. And come over here and hit the touch-off button in UCCNC. Up comes my box asking what my nominal thickness is. Now I'm not using one at this stage, so I'm just going to hit the enter key. The cutter starts heading down and it touches the block. It bounces up again and comes down again, touches the block a second time and then bounces back up. So far it's working exactly as we want it to. So next I'm going to take a piece of MDF here. This is 18mm MDF, and I'm just going to run my touch off again. Again, no material thickness offset, so we'll just let it touch off like so, and that's great. Let's do a return to origin point, and that'll drive the cutter down to the surface of the material. Here what we're doing is we're checking that when we measured the thickness of this block using our calipers, that the figure is correct. So if it's correct, there'll be no up and down movement on the block, and there isn't. The cutter will not cut into the block, which it isn't, and if I look down here, I see no light passing under the cutter, so I've got my thickness correct. Okay, so we've got one final test to run, and that's checking the nominal thickness functionality of our macro. So I'm going to put the block on the spoil board here, and I'm going to bring the cutter up and over the block. Come over to UCCNC and hit the tool setting button. Up comes our box. I'm going to enter 18mm this time and go enter. Our cutter touches off a couple of times and sets itself to the final retract height. And now I can go origin point. You can see here the cutter is returned back to my stock and is sitting on the surface of it. Now don't be alarmed if you find the cutter is sitting a little bit above the stock or a little bit below it. The cutter is now 18mm above the surface of the spoil board, and my stock probably isn't 18mm. In actual fact, mine's a little bit more than 18mm, so it's pinned to the spoil board. And that's the whole point of this exercise anyway. It's to compensate for inaccurately sized stock. Okay, well this is working, so I'm going to give it 2 thumbs up. So, question of the day, what value should I enter when using the touch-off plate? And I'm presented with the question of what the material thickness offset is. Well, it's very simple. If I have my block of material here and I put the touch-off plate on top of it, the answer is simply 0. And we don't even need to type in 0, just hit the enter key and away it'll go. It'll touch off the surface and 0 will be set to the top of the material. So the next question is, when I put my block on the spoil board here, what's the nominal thickness value I should use? Well, again, the answer is very simple. It is the nominal thickness value that you used when you created the file in your CAM software. So let me elaborate on that. If I was creating a file for this piece of 18mm MDF, I would tell my CAM software that this piece was 18mm thick, and when the G-code was imported into my control software, about Mac 3, UCCNC, Linux CNC, what have you, as far as it's concerned, the material is 18mm thick. So when presented with that question and setting my cutter with respect to the spoil board, the answer is easy. It's 18mm. And 99.99% of the time, you're not going to have a problem with that. But if you remember back to last week's episode, I didn't have the file to create a new section of G-code for the piece I wanted to cut. And it was created for a piece of 18mm plywood. Unfortunately, the plywood I was using was just under 20mm thick. So when presented with the question, what is the nominal thickness of my material when I set the cutter onto the surface of my spoil board, the answer was very simple. It was 18. That's what I told my CAM software it was. That's what my control software expected it to be. So just be aware of that. It isn't necessarily the actual thickness of the material you're using at the time, though most of the time it will be, because you'll be using files specifically for that material. But if you're changing material like I did, it's always the nominal thickness value you told your CAM software that the material was when you created the file. Well, there you have it. Wiring up the touch-off probe was really easy. Configuring our software was really easy. And remember, you're not stuck having to use this particular style of touch-off. You can use this style here with a movable touch-off button, so that if anything goes wrong, you've got an opportunity to push the emergency stop button and prevent a disaster with your cutter. What style you choose to use is entirely up to you, and there are plenty of different styles out there. If you're looking for the files I used, follow the link directly under this video. You'll be taken to a page to where I have the files saved. You can download the ones you want to use and just check you're using the most up-to-date version. If you find anything wrong, please let me know. I'll get it fixed and updated as soon as possible. Well, that about wraps it up for this episode. Don't forget to like and subscribe and join me next time. I have no idea what we'll be doing, but there's a good chance we'll be using our new touch-off plate. Okay, cheers.